Hey YouTube, is my voice clear now? Is my voice clear now? Let's see. Is uh-huh. Uh-huh. Let's see. Okay. Okay. Okay, sounds good. So, let's uh start. Hello, hello, hello. Okay, so I can. Okay, that's great. That's great. That's great. That's great. Okay, let's see. So, I'm creating this stream, or I'll try to create a stream every day to solve 3 problems from each study plan. Like for this one, we try to solve the first 3 problems from the binary search study plan. And this streams we try to focus on one single aspect and just try to get deep into it to improve ourselves in this matter. If you have any question, feel free to ask. I will answer them like immediately once I see them. I have the chat right now, so just like feel free to ask me. I just put this one in the chat so anyone could ask me if you want. Let's see. Let's start in the first one here. So the first problem number 704, called the binary search. Given an array of integers called nums, which is sorted in ascending order, and an integer called target right function to search target in nums. If target exists, then return its index, otherwise we return -1. We must write the algorithm within O of log n runtime. So because if it's of O of log n runtime, it should be a binary search algorithm. You cannot do anything different. So the way we can do this one, let's just talk about how binary search work. So let's say that we have this one here. And let's just open this one to talk about it. Let me delete all of that. Just start clean. Thank you. What's going on? So sometimes Miro doesn't seems to work well, and it needs some, yeah, and a T. So basically, the binary search, it works like as following. First, we have we defined left and right. Okay, so this let me have the pen. We defined left and right. Okay, and when we define left and right, we try to find all possible indices that will be we try to find all the possible indexes that will be add up to the target. So we try to have left and right. We try to find the middle element, will be the middle between left and right. So let's say it will be 5. So we try to find, is 5 equals to target? If that wasn't the case, if 5 doesn't equal to target, so we say, okay, if 5 bigger than target or smaller than target. I guess 5 is smaller than target, and since 5 is smaller than target, and this is a sorted array, that means all the other numbers that on the left of 5, including 5 itself, will not equals to the target. So we take the left and we put the left here, so we create a new subarray between 9 and 12 to see if the actual element lived there in between both of them. So by this one, we have O of log n instead of having O of n or O of n squared. So this way that binary search works. So let's just see how this work in action. So for example, let's start we create like let, I will have like left or right, or like let's call it start and end, because start and end it will be easier to understand. Let's start and let end, it will equal let end, and end it will equals nums the length -1 -1, and I'll create a while loop. A while start is smaller than or equal end, and I will say okay, let mid equals math dot flow start plus end and divided by 2. And since I created a mid, I'll try to compare the mid with the target. So I will say okay, if nums of mid equals to the target, if that was the case, that means we found everything, so we return mid. If that wasn't the case, else if nums of mid smaller than the target, that means we should update, if it was smaller, should update the start. So start equals mid +1, and the last else, if basically if the nums of mid is bigger, that means I should update the end. The end it will equals mid -1, and I will if I didn't find anything, I'll return -1. And let's just try to submit and see the code here. It seems that it's working. However, I'm not beating that much. Let's see why I'm not beating that much. Like the people that done it better than me, how they did it. Well, this is not binary search though. It's a hack. It doesn't. It's not good. Let's see. Like maybe someone here is doing it here. Let's see. Maybe we have someone here. Start and end. I guess he's doing it the same. I don't know why. I am quite smaller than him, but anyway. So yeah. Okay, let's continue. So we continue the next one, which will be the search insert position. Okay, let me delete it. So so here it's we try to we have like we given a sorted array of distinct integers and target value. We will return the index if the target found. If not, we should return the index where it should be. If we're instead of the order. Okay, we should also make all again. The only difference right now, if we couldn't find the target, we should return where the target should be. And let's try to think about this one, because it's a quite interesting one to think about. So basically, let's just try to see. First, we could just create a binary search, and we could use like left to return something or not return something. So let's just try to search. So first I could create let me just do something here. Do I have any comments yet? No one is commenting. Okay, so let's just create I guess I have an error with my internet. Let's try to do it again. Okay, so let's just try and okay. So first I'll create the left and right. equals 0, or let's call it start and end. Let's just stick with start and end 0, and let end, which will equals nums dot length. And I'll try to return start, because if I couldn't find it, I'll return start, because I expect start should be where the index should be. So I'll create a while loop, and I'll say, okay, let as long as the start is smaller than end, and I will create mid first. Let mid. However, the mid will equals the start plus math dot flow. Okay, we have start minus end. Let's just do it again like that. Divided by 2, 2, 2. And I'll say that, okay, if target is bigger than nums of mid, that means left will equals mid plus 1, I guess, plus 1, yeah. Else right will equals mid. Okay, if you don't understand this one, do not worry. Let's try to describe it. First, let me submit and see if it will work or not. What? Don't tell me it will be time exceeded. Don't tell me it's time exceeded, because it shouldn't be. Let's start and there is nothing called left, and there is nothing called right. Start and sorry, wrong answer. The target should be 5, and I got the output. I expect it to have 2, and I get return 0. What did I do wrong? Start minus end. Wait a minute. End is the bigger, and yeah, sorry for that. So let's try to describe what did happen here. And something with the internet with me. I don't know what's going on. Anyway, let's try to talk about what we have done here. So first, in this one, we try to in this one, if we can use a binary search, like posed on the description of the problem, that we have to use not the tutorial. Why I'm going to the tutorial? Yeah. Based on this one, like, we should use a binary search. If we find a target, if the target is equal to the value, to the middle value, the job is done. If the target is less than the middle of value, we continue to search to left. If the target is greater than the middle of the value, continue to search on the right. And here's the way that we do it. Basically, if you want to know something here, because I guess most of the stuff you say, like, why start plus? Why start plus? Why start plus? But the thing that, like, let's just try to stress, like, the middle will equals left, like end plus start plus divided by 2. But however, this is different equation to find the right one. This is different, way different equation. Like, let's see, could we do it with plus? Maybe we could do it with plus, but I guess we couldn't. It will not work with plus. Let's see. Yeah, it did work. Okay, it did work. No need to scrub anything. It did work. So yeah, let's go to the third problem. How many times did I get right now? I guess I should open the live stream. It's I only have one view. Oh, that's bad. That's bad. Okay, and I have one like. Okay. Do I have any comment here? No comments. Okay. So I have right now here the find the smallest. Let me try to delete all of that and read the problem and see if we can solve it, because it's been very long time since I touched this problem. Let's see. So we should find the smallest letter greater than the target. So you are given an array of characters called letters that is sorted in non-decreasing order, and a character called target. There are at least two different characters in the letters. Return the smallest character in letters that is lexicographically greater than the target. If such a character does not exist, return the first character in. Okay. Let's try to think about this one, because we could solve it in the same way, I guess. Like, I guess we could solve it in the same way. Like, we could just create like first, I'll say I create like a base case for my mind. I'll say if like letters dot length equals 1, I should return letters of 0. Okay, the first one. Make return better. I'll create let left equals to 0 and let right equals to letters dot length and I'm gonna create a while loop while left is smaller than or equals right. Maybe I could make it start and end, and I will say I will create mid const mid will equals math dot floor. It will be right plus left divided by 2 and I will say okay if the letters of mid equals if the letters of mid less than or equals the target, I will left will equals mid plus 1, and else right will equals mid minus 1. And I could just go outside of the loop and basically if left, because I'm trying to make sure that left will equals the actual element. So I'll say that if left equals the letters the length, that means we couldn't find anything. Okay, so we return letters, we return the first element. Otherwise, else we return the letter of left, I guess. Well, I guess that will work, right? Let's see. Oh, okay, that works. So yeah, okay, that was decent though. That was decent. So okay, let's see. So yeah, so basically it was basically like the same before, like, but we just like tweak in it. Instead of doing the left or right, I start to store everything in the left, and I just make a check here. If the left equals to the length, that means we couldn't find it. Otherwise, we keep it there. So yeah, that's it for today's video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future stream. And this is my first stream, so I'm pretty proud about it. Let's me end this live. Stop. No. Let me stop. How to stop stream? Okay, we end the stream. End.